We've done all that sort of stuff. If you're looking for work like that, feel free to hit me up or look up our website. I've got it up there. Personally, besides the company, I do red teaming mostly. I perform vulnerability research on the side. I really enjoy that. And I also helped co-found the Houston Area Hackers Association. If you've heard of AHA, the Austin Club, this is the Houston branch, kind of the same deal.
Hi, I'm Michael Mason. I work in the web hosting business as a data center developer with a primary goal of automation and DC monitoring. I love to figure out quick ways to remove tedious tasks and to simplify daunting ones. I work primarily with languages like Python and PHP, and I'm an active watcher of HaHa.
He is. He shows up and listens several times. Real quick, just kind of in general what this is about. Again, if you thought this is about digital cameras, it's not. I apologize for the confusion. Basically, we're going to be looking at Device 42. This is a data center infrastructure management system, which is a just silly phrase that means it's software that helps manage data centers. By the end of this talk, we're hoping you'll get a couple benefits from this, depending kind of on your role in the organization. If you're on the red side of things, like I am doing vulnerability assessments or pen testing, you're going to walk away with a functioning exploit for Device 42. The old version, they just patched this. And a tool. You can go home Monday morning and start popping boxes if you work for a client that has this. Also, if you're interested in performing similar research, we're going to cover kind of high level what our methodology was, why we looked at what we looked at, and hopefully you can go home and work on that too.
So if you're on the blue side of things, there's already a patch out. I'm sorry? What? You sure? Yeah. Okay. So if you're on the blue side of things, there's already a patch out. If you haven't already downloaded it, you'll want to go ahead and do that now. We also have cover some other mitigations that we'll get to by the end of this talk.
Oh, that's also you.
Oh, just kidding.
I don't want to.
So what is DCIM? DCIM stands for Data Center Infrastructure Management. It's basically a fairly broad term that can range from tracking physical assets to managing passwords. This field has been rapidly expanding since about 2013, and there's some big name players such as Sunbird, LabTech, Cormant, and Device 42. Device 42, we're going to take a look at Device 42. Device 42 is sent to you as a virtual appliance. This means that they send you a VM file that you'll put on a virtual host, and it comes in different formats like VMDK and raw images. Device 42 has many features like rack elevation, room layouts, device connections, passwords, password management, software, and power management features. It is used by many large companies and keep track of their most valuable assets.
So we're going to talk about that real quick. If you look at this list of company logos, you'll notice some of these are really big companies. This is straight from Device 42's website. It's just to kind of give you an idea of who's using this. You probably recognize most, if not all of those, except for maybe like the Beijing University of International School of Beijing. I didn't know them. There's quite a few big names. You know, there's tech giants on there. There's communication giants, Verizon. My personal favorite is MITRE is on there because we approached them with this bug and asked for a CVE, and they're like, no, we don't cover that product. And I was like, but you guys use this product. They're like, that's right, but it's not covered by CVE. So you can't get a CVE code. And I was like, okay, whatever. We'll release it without one. So we don't have a fancy code. We don't have a funny name either. We originally brought up this list because what we wanted to talk about was, in addition to the bug, how having a customer list might be dangerous. How if you had, say, RCE, and you had a list of customers you knew were running this product, you had a list of targets. But that didn't really work out. As far as targets go, we'll kind of get into what we looked at with them a little bit later, but we want to move on to some of the more interesting stuff. So I mentioned research methodology. I was going to kind of tell you what we worked on, how we went through the research side of this to find the bug before we get to the bug, and then we'll kind of talk about both and tie them together. I don't really have a formal methodology. Like I can't say, go check out so-and-so's blog. This is exactly what I do. There's several that kind of work depending on the field of research you're doing. But I haven't really seen one I like for full appliance research. Jason Haddix has a web bug hunting one. He did a talk called How Do I Shot Web, like 2 years ago, maybe a year or two. It's great for web bug hunting, not so great for this. It's a little bit different. What we did use a lot of was there's a guy named Tobias Klein. He wrote a book called A Bug Hunter's Diary. It's a great book specifically for finding code or bugs in code like C or C++. We used some of his techniques. I like the book so much I've started it twice, though I haven't quite finished it. All right, but he has a really good preferred technique that applies mostly to C and C++ systems, but we're able to use it here for really any code audit. Basically, his technique is, and you've probably heard something like this before, right? Find the inputs, take those, trace them through, look where they're going, what kind of functions they're going to, because inputs, especially from users, are untrusted, and that's where your fun, dangerous stuff goes. That's what we did. In addition to that, pen testing in general, I've got another friend named Tim McGuffin. He does red teaming with me and a few other people. He likes to say that pen testing is like D&D. If you've played D&D, you sit down, you've got some set of tools and knowledge, and your DM goes, you're in a dark room, what do you do? And that's pretty much what this was. We sit down with some appliance and go, okay, we have this dark room, we don't know anything about it starting out, what do we do? And it's gonna change depending on your background, what your tools are, your class, or whatever. Also, as far as appliance research goes, it's pretty much post-exploitation. If you do network pen testing, this is pretty much the post-exploitation phase. You take over a box. In this case, it's pretty easy to do because you own the appliance. And you start looking at everything it's doing, how it's doing it, why it's doing it, and then you follow through. You trace the inputs, find the outputs, and follow through just like an application.
So, so let's apply the previous slide to our box. Before we have a shell, we can post or we can port scan the box and see what it has. The appliance has two web interfaces and an SSH interface. In according to the documentation, one of the web interfaces is the front end, the primary interaction interface where you add servers, add passwords, rack servers into server racks. The second interface is the appliance manager, where you run backups, set your security passphrase, where you can do some tests as to why the box isn't working or whatnot. And then also the SSH. The SSH interface is where you'll configure base things like the networking and stuff like that. Documentation is a great resource for any research. I highly recommend consulting RFCs and documentation. The network services are great for an attacker, but as a researcher with full control, we own the bootloader. We can just edit the grub, set init bash rc or init bin bash in the grub, and we have full root on the system. In any VM appliance, this is a great starting point. This should pretty much always works. It's like having physical access to a machine. If you get physical access, like it's not in the cloud, then it's game over. That being said, this really only allows people with DC access to take over, but it also allows us to look further into the system to start post-exploration phase. One issue that we found with all boxes having the same default SSH creds, additionally, it does not force you to change those passwords during the configuration. This is not recommended as it allows users to keep the default creds, allowing them to be more susceptible to attacks. This was found in the documentation. Like we said, documentation is a good starting point.
That's actually a screenshot of the documentation for Device 42. They have great stuff like, this is the password, please change it. Linux has a command to force you to change passwords on login. They didn't bother doing that. They say, please do it.
So once in the system, we first began looking into the shell that Device 42 uses, and we noticed that it was launching a startup script located in the user's home directory. Taking a look at the startup script, we saw multiple commands being ran with sudo, and so that made us look at the sudoers file. Like Caleb mentioned, look around what files are in use, and if a script is running as an elevated user, look into why. When we looked at the sudoers file, we discovered it was configured very poorly. As you can see here, the sudoers file has sudo no password all, meaning you can run all commands without the password, And I don't see anything wrong with giving no password, but it should be limited to a list of commands.
Cool. So taking this all back to the methodology real quick, like we said, looked at documentation, right? Initial information discovery, this is pretty standard stuff. You find weak points like default creds. If you log in, we told you how we walked through and found why we looked at sudoers file. We looked at files in use, they point at this file, and this file has problems. So we have an initial foothold. We can log into the SSH interface, and we have sudo all no password. That should be a root shell, right? But like Mike also mentioned, root shell if it's in the default configuration. The default shell for the user you log into is not bin bash. It's this other file called reboot bash that just launches this script. This is what their default interface looks like. All you can do is like set up the network, set up NTP, install VMware tools. You can't run commands through this. There's nowhere to break out and run your own shell. So you can log in, you technically have sudo privileges, but you can't run anything. So it's not super useful. So as an attacker, if you came up on this box and you knew the creds, you'd still need a way to break out of this. Control-C doesn't work, Control-D doesn't work, it's nothing quite that simple. So what we did was using our initial shell we got through the bootloader, we could actually just read this because it's shell script, right? It's nothing, it's just totally trivial to read. So we actually just started doing code audit on it, kind of like going back to the Tobias Klein methodology, find the inputs, trace them, see what they're doing. That's exactly what we did. This is actually the set NTP function in that shell script. You may or may not be able to read the code all the way in the back, but I've highlighted 3 lines that are interesting to us, and then I'll go to the next slide and I'll blow them up so you can read them a little bit better. But the first one, we've blown it up there, is read-a input. So this is our input, right? We want to trace inputs. So this is the first interesting line to us in this function. A lot of functions take input. We're showing this one because this is where the bug is. We can't go through them all right now. The second line is a fork in code. It asks you a question about creating a cron job. If you reply yes, it goes to this third line, and this third line is the vulnerability. Sudo shell-c just means run a command through shell as sudo, and then if you look, it just concatenates our input straight into a little single quote. Just kidding, I'm gonna stay right here. Anyone who's done an injection attack, you can already see exactly what we're going to do. It's just like SQL injection. It's just like command injection. They're basically running eval. If you've done this like in PHP, same thing. So we're just going to walk through how we broke out of that and ran bash commands. Again, we can also run bash commands with sudo all no password, so we can run anything as root too. That's our injection. We blew it up. You can see it at the bottom. So we have any string, right, and a single quote just to close out their single quoted string. Semicolon kills the bash command. And then sudo su just runs su, right, run as root. And then we needed another command to catch their single quote, so we echoed another string. And then that's just going back to the code path. This doesn't actually happen until you reply equals yes. So we have to wait until the code says adding to a daily schedule, yes, no. If we hit yes, we hit the second code path, it concatenates our input. You can see NTP fails out a bunch because it's trying to resolve that injection as an NTP host name, which is, it's not a host. And then we get root at device 42. Then we get root. Yeah. Okay, but it's no fun to see pictures, so we're actually gonna do it too. All right, Mike, you wanna hold this?
I can hold it. Now what?
Near me.
Oh, okay.
Oh, no password? No, I accidentally hit enter. Nice try. Okay, closer to me. So we're gonna do all that manually real quick. It's the exact same thing as the screenshots, but we figured we'd show you. Default creds, this is or actually I guess I can show you the other box real quick. Come on, VMware. Oh, it's hiding. So this is that same interface. You can see we're just running the default VM, no configuration changes. We just downloaded it, snapshotted it, and restore that snapshot whenever we want to break it fresh. Nope. Okay, so we're just going to SSH in 56.128. And I guess they tried to hide SSH. It's on port 404. I don't know if that's like a joke of theirs, but port scan will find it.
I couldn't find it.
And then we're going to do the default password from the documentation, just like you saw a minute ago. And we're logged in, and we're in that same thing, right? Can't control C, it just breaks it. Can't control D. But like we showed you, if we run the NTP function, we can do our same injection attack. So it's going to ask us, what host do you want to use? BSides, semicolon, space sudo. Hard to see. Nope, missed the O. Su, echo, DFW. So same injection, just BSidesDFW. The strings don't matter, they're arbitrary. And then this, the time it takes for NTP to fail out varies depending on how their DNS is set up and what it's trying to resolve. It can take anywhere between like a couple seconds and like a minute. We tested on the same network earlier and it took like 10 or 15 seconds, so it'll fail out. You can see it's just trying to resolve, oh, I can't go that way. I remember now. It's trying to resolve host bsides single quote semicolon. Obviously, that's not an NTP server. Same thing with each part of our command is trying to resolve it. The reason it's resolving a bunch of them, I think, is because it's just reading them in as arguments, the NTP. But if we give it a second, we'll get to that second line we highlighted where it says, do you want to add a cron job? Yes, no. And if you remember from the code, we want to hit yes because that puts us on the right code path. And then it should give us our root shell. And there we have it, root at device 42. There's our ID, we're running as root, and IP A ETH0.
Show ETH0.
Not A show. There's the IP that we are on. So we got our root shell. It's pretty trivial to do. But then we were like, why have to type that in every time, right?
So we've gone ahead and we've written a script that will basically do everything that we just did, but quicker. It takes about 42 seconds, or at least that's how long the video is.
That's the manual one.
The manual way. So why not knock off about 15 seconds? The script is written in Bash with to accept the arguments, and then it uses expect to launch the SSH session and run all the commands. So we're going to go ahead and reset the VM.
This is just so it's fresh every time because we don't want to re-exploit the same box.
Alrighty, so if we go ahead and look at ls, so this is the file actually. ls, hold on. So this is a file. This is on our GitHub, as you may have seen on the previous slide. You can run this without any arguments to see the help. You can pass the host, the IP address or a fully qualified domain name. And then optionally, you can pass username, password, and port if you've changed any of those. You can pass those. If you don't pass any of those, it uses the default credentials as it showed on their documentation. So we'll go ahead and run it with the host. Hit enter. And there it goes. So as you see, it uses the ASDF as it showed in the slides. But it's going to do the exact same thing. So right now it's going through the, oh, okay.
Stop it.
Oh, yeah. So it's just going through and trying to resolve those host names again.
So it's the exact same thing. It's just automated. If you want to wait like 5 seconds, we can let it finish failing out, or we can just move on. Poll, audience, fail. Let it fail out. All right, we'll let it fail out.
I'm now holding the mic.
He is Mike.
I am Mike. Mike's Mike.
There we go.
And there you are. So there it is. We can go ahead and ID shows we're root, and
You made no spaces in that.
what?
Do you not believe in spaces, bro?
No, it's about tabs.
seatbelt show.
Did I really?
Hey, sir, please,
There.
please calm down, sir.
Whatever. It's the same IP. So as you can see there, that's our Git for it.
Oh, yeah.
Is this one also mine?
You guys want that? This should be available somewhere afterwards too, if you want. Sorry, this should be available somewhere afterwards too, if you guys want the links. Oh, sorry, I didn't remember.
Oh. All right. So so what can an attacker get from this? First, information. Information is worth a lot. And a box that manages other boxes is a chock full of good stuff. Second, credentials. This is a box that manages other boxes, including password management. This is a post-exploitation gold mine.
Right. So, all right, Caleb, Mike, sure, this box manages passwords for other boxes. How does it manage those passwords? What is it actually doing with those? So we're going to jump back to real quick. At one point we mentioned we did service enumeration on the box, right? We wanted to see what was on it. One of the services is a Postgres database. Now, it's not network facing. You have to break into the box before you can reach the database. But once you do, the credentials are, anyone want to guess? Default for the Postgres database. So once you're on this box, which we've shown is pretty easy to do, you can just connect into this Postgres database and you can start pulling data out of it. Now, they do store passwords for all your servers there if you choose to use the password management feature. Now, they are encrypted as well, but this box is designed to be used offline, like in a data center, away from the internet. So all of the encryption has to be handled locally. So basically, you set a passphrase when you first set up the box, and that passphrase is used to encrypt all the passwords. That passphrase may or may not also be encrypted with a different hard-coded key. We wouldn't know because we asked Device42, hey, we're pretty sure we could decrypt passwords in this once we broke in. Can we test that? Because technically it's against the EULA because you weren't allowed to decompile the Python. They told us no. So of course we didn't do that because that would be wrong and we would never want to break a EULA. So we totally didn't do that. But theoretically, an attacker could get a shell, find the Python in charge of the decryption and reverse engineer it and pull all the passwords off of this box. Again, we wouldn't do that because we're ethical researchers, but a hacker, he totally might.
Okay. On a default install, is there any password that always shows up in the database where you might be able to do a plain text attack?
So
if you knew that there was a password that was always in there,
right,
then you could do a rainbow table or anything you want.
So the question was, did we check if there's a default password that we could do plain text attacks or try to like brute force or guess? There's not. It comes with a blank database. But again, we would totally never do this. It's totally theoretically possible, but we would never do that. We couldn't find a way to ram it into our testing, not ethically. So then we're going to talk about the patch real quick because they did patch the bash injection, which was the most glaring vulnerability, except for maybe default creds. We'd like to note that our interactions with Device42, the company, it's also the name of the product, were actually pretty good. They got back to us reasonably quickly. They did patch this. Their interactions with us were mostly happy. They were just kind of like, hey, please don't get a shell on the box. After we did this, they put the words, do not attempt to get shell into the EULA. So in addition to not decrypting passwords, you now can't get shells. I mean, you can, but you can't because it's against the EULA. But overall, our interactions with them were good. They were happy. They fixed the bug. They were glad for the report. We didn't fully test the patch. We'll just kind of talk about what it looks like they're doing here real quick. It looks good. Basically, they take your same input, and they just echo it through grep, and they compare it to a small white list of characters. So alphanumeric, underscores, dashes. You can't get single quotes in. You can't get semicolons. Hard to break out of a string when you can't put any sort of quote mark.
And actually, additionally, you can't see it here, but
Yeah, we didn't test anything beyond this.
One thing that's not seen here is they also removed the -A on read input. So even if it got past here, or it won't get past now.
The -A turned it into an array. I don't know why they removed that. It didn't seem to make a difference.
Couldn't you put in bytecode or hex?
So he's asking, could we put in bytecode or hex? Maybe. We tried no sort of encoding attacks. We looked at this and we said, okay, well, they've tried and we're kind of tired of looking at this box and we don't work for Device42, so we don't want to spend more time trying more attacks. There's other issues anyway that aren't yet resolved, but these were the more glaring ones, and these were the simple root shells. This is all patched as of update 11.0.0, so if you do run device 42, get that patch. And then real quick, I want to touch on post-research, sticking with the, if you're looking into research topic. Say you found something like we did, right? Root shells remotely on a box is a pretty big deal. It's kind of cool, especially if they're big name customers running that box. But post-research is a large separate topic. People talk about this. People say you should go one way or the other. Basically, there's 4 avenues you could take if you get a good finding. You can do responsible disclosure, which means you give it to the vendor. You wait for them to fix it before you release it. That's what we chose to do here. This is already patched at this point. There's full disclosure. If you're like, no, Caleb, information must be free. I'm releasing the bug as soon as I find it. Go for it. I'm not going to stop you. Some people like to sell bugs. If you get really good bugs, especially in big name products like jailbreaking an iPhone, Zerodium will pay out the nose for it. And then finally, you could hoard bugs. You could be like, no, I put my hours, months, weeks, whatever into that bug. There's no way I'm giving it to someone else, and hold on to it and just tell your friends, look how lead I am. I got a bug. If you do that, feel free to share bugs with me. I think that sounds fun. Like I said, in this case, we reported it for free. Device 42 has a responsible disclosure program that says, give us the bugs. And they don't give you money, but they were pretty nice. And then finally, if you do that and you do want to share your bugs somehow, either responsibly or fully disclosed, you can share them at a conference. You can teach other people or use it as a learning opportunity. That's kind of what we did in this case. I'm not saying any of those 4 paths are the wrong one. Do whatever you want.
So what are some mitigations? The vendor recommends placing device 42 behind a separate firewall. Their appliance manager, although you can do a lot of things, one of those things is not configuring the firewall. They said that they are looking into doing that, but they currently don't have that. Additionally, change the passwords. There are, I believe, 3 different default passwords, one for the appliance manager, the console or SSH, and the front end. Make sure that you change all of those. So this slide here ties back to the customer list we were talking about. We were hoping to show how many of their customers had their boxes available to the public. However, we came up empty. We tried to scan, as you see there, about 16 million IPs that were pointing towards or is owned by those customers. But with that, we didn't find any port 404 SSHs open, and we don't really. I just mind blanked. They could have been on a different IP space that we just didn't scan, we didn't know, or they could already have a firewall in front of them. So we didn't want to perform entire internet scans, as that is another topic. However, we did do a basic search on Shodan. Shodan showed that 10 Device 42 appliances were running in the public, and about 1/3 of those are using fully default configurations, creds and all.
Yeah, so if you're like, hey guys, your mitigations are basic and stupid, there are at least 10 people that do not believe placing it behind a firewall is stupid, and there's about 1/3 of those that don't think changing the creds is stupid. So it totally happens. And like I said, we didn't search the whole internet. There's probably more, but we didn't really care how many other people were doing it wrong, as long as one was, so we could say, don't do it wrong. There are people who do that. So let's go ahead and look at the conclusion. We're going to kind of wrap this up a little bit early. First of all, you should look into assessing your DCIM software if you run it, if you work in a data center. Really, you should look into having all of your software assessed if you're using software for your business. But we're specifically talking about DCIM, so I'm not going to talk about the rest of it. There's a handful of ways you can do this. You can talk to the vendor, ask them if they've already had an assessment done. If they've done an assessment, what was the methodology or who performed the test? Can you get a copy of that report? If they've not had a formal assessment, do they at least have a responsible disclosure program? Do they have a bug bounty? Has anyone ever turned anything in through those? Is it actually being looked at? That's kind of important for software. You want to make sure it's safe. Moving on from that, if you want to do research, kind of like what we did or more other research, I mentioned the book earlier, Tobias Klein's A Bug Hunter's Diary is great for like C-based research. It's kind of just like stories of what he did. But if you're looking into research, I like starting with something like an appliance. They're really easy to start researching. You get a full box, especially a virtual appliance, you can just download for free. You get a full box, you have control of the bootloader. You can always edit the bootloader to get your initial shell and start looking around. It's way easier than trying to like do research on a cloud-based service where you've got to try to break into their actual legit running servers. This is pretty much a post-exploitation gold mine, like we said, for any appliance thing. You can get a shell and start looking around, and once you can look around, you can find the problems in their bash scripts. Just look at what you have in hand when you're doing research. Keep in mind the whole system. Take notes about what you found. Like if you find Postgres and later on you're saying, gee, where do they store their passwords? It's probably in Postgres.
So like we said, a standard mitigation is network segmentation. This seems obvious. People have been doing it for almost as long as there have been networks, but it doesn't always happen. In our very limited look at the internet, there were several boxes exposed. If you have device 42 specifically, lock it down, change the creds, put a firewall in front of it. Also, still look into an assessment. There are many parts of this and features of this appliance that we did not check.
Yeah, the whole 2 web interfaces we didn't even hardly touch. There's a lot of features on this appliance that we just didn't get to. We got a root shell. We found a handful of other stuff. We turned it all in. And like I said, we don't work for them. We didn't want to put all our time into helping them, so we moved on to other things already. So if you still run this software, patch it, put the mitigations in place, and probably have it looked at anyway. If you're on the red team or doing red team sort of work and you're working for a client who has this box, go get your shells. And if you're on the blue team...
Yeah, if you're on the blue team, make sure you work with those red guys. They're not so bad.
We're going to go ahead and wrap up here. Again, you can contact us a few ways. I'm on Twitter at CalebWatt15. That's the page for the Houston Area Hackers Association. If you're ever in the Houston area, once a month we meet up and talk about research we're doing or interesting projects we're looking at. The tool, again, is on my GitHub. If you want to download it because you have a device 42 box you need to pop, like now, it's there, it's public. And then finally, you can reach Mike Mason at DCIMDestroyer@MikeMRM.com. That's totally his normal email. We didn't just make it up for this. Yeah, We're going to step out in the hallway. If anyone wants to talk to us, just let the room clear out and the next talk gets set up just so we get out of the way. We'll be right around here if you guys want to talk about this or anything else we found. Thank you.